Today in geometry, we are going to look at measuring and classifying angles. In this first diagram, we have an angle, and we have its vertex A. The vertex is where the two rays come together. An angle is made up of two rays with a common endpoint. So here we have ray AC. This is a ray, and the other ray is AB. Okay, so there are two rays, and they are meeting at this endpoint A. Okay, we can name this angle three different ways. We could just call this angle A, and that would be fine. We could call it angle CAB, or we could call it angle BAC. In either one of these cases, these last two cases right here, you'll notice that the vertex angle has to go in the middle. So if we start at C, we can start at C and go to CAB, or we can start at B and go BAC. In either case, either way is totally fine. You just have to make sure that your vertex angle is in the middle. When we look at this second set of angles, though, we cannot name this with one single letter like we could in the previous angle. Here our vertex is X, and the problem with just naming this X is that there are three angles at X. We have this small angle right here, we have this small angle here, and then we have the big angle. So we have three angles, and anytime there is more than one angle at a vertex, you have to name the angle with three letters. So if we are talking about the smaller angle at the top right here, well, there are two ways to name that. We could name it WXY, or we could name it angle YXW. Either way is fine. If we want to look at this smaller angle at the bottom, we could call that angle YXZ, or we can call that angle ZXY. Again, the vertex angle has to be in the middle. If we want to look at the big angle, this whole thing right here, then we can call that angle WXZ, or we can call it angle ZXW. Okay, I want you to notice the common thing in each one of these angles. X is the vertex angle for every single one of these, and X is in the middle when you name these. Your vertex angle, the vertex letter has to go in the middle. Let's quickly review these four kinds of angles. An acute angle has two rays and a vertex. We'll call it angle A here. And an acute angle, in this case the measure of angle A, has to be less than 90 degrees, but it also has to be greater than 0 degrees. Okay. A right angle. A right angle will be denoted always by a little square in the corner. If it doesn't have the little square, then it is not a right angle. Okay, so we'll call this angle B. Okay, in this case, the measure of angle B has to equal 90 degrees exactly, no more, no less. An obtuse angle, okay, we have this angle, and we'll call this angle C. Okay, if it's obtuse, then angle C, the measure of angle C, has to be less than 180 degrees, but it also has to be greater than 90 degrees. A straight angle is exactly what it says. It is straight. Okay, so if we call this angle A, B, C, then we would say that a straight angle has to equal, we'll call this angle A, B, C, has to equal exactly 180 degrees. In a previous lesson, we looked at the segment addition postulate. In the segment addition postulate, we took small segments and added them together and got a larger segment. The angle addition postulate is the same thing, only we will be dealing with angles. When we look at this first diagram, we have angle RSP, and if we add it to the other small angle, which is PST, we will get the larger angle of RST. Okay, so let's write that down as an equation. angle RSP plus angle PST is going to equal the larger angle of RST. That is the angle addition postulate. Now let's apply the angle addition postulate to this second diagram. If we are given that this large angle here is 145 degrees, then we can apply the angle addition postulate. Okay, we can say that angle LKM right here plus the smaller angle at the bottom, MKN, equals the larger angle of LKN. Now that we have the equation written, we can substitute what we know in. They tell us that angle LKM is 2x plus 10 plus angle MKN is 4x minus 3. And that equals LKN, which they told us was 145. Now we'll combine our like terms. 2x plus 4x gives us 6x. 10 minus 3 is a positive 7. That equals 145 degrees. Now when we subtract 7 from both sides, it will eliminate this 7 here, and we will get 6x equals 138. Now we divide both sides by 6, and we get that x equals 23. Okay, now we've solved for x, but how do we find out the length of each one of these angles? We can take this x equals 23 and substitute it back into each one of these expressions. So 2 times 23 is 46, plus 10 is 56. If we put 23 in for 4x minus 3, we have 4 times 23 is 92, minus 3 is 89. So when you substitute in here, you have 89 degrees. Now when you add these two things back together right here, they better give you a sum of 145. And they do. 56 plus 89 equals the 145 that it says it should. This is the last thing that we are going to look at, and we have to have some knowledge of what a straight angle and a right angle is in order to be able to solve this. If we know that KLM is a straight angle, then we know that the two angles that make it up must add together to be 180 degrees, because that's the definition of a straight angle. That means that 10x minus 5 plus 4x plus 3 has to equal 180 degrees. Now we can solve for x. 10x plus 4x will give you 14x. Negative 5 plus 3 is negative 2, and that equals 180. Now we'll add 2 to both sides to get 14x equals 182. And then we will divide both sides by 14 to find out what x is. And when you do that, you're going to get x equals 13. Okay, that's great. That is what x is, but what is the degree measure of each of these angles? Again, we're going to take it and we're going to substitute that value for x into each of these expressions. So we'll have 10 times 13 minus 5. Well, we know that 10 times 13 is 130. Minus 5 would give us 125 degrees. If we take 13 and we substitute it into the expression 4x plus 3, we'll have 4 times 13 gives us 52, plus 3 is 55. So if we were to add 125 plus 55, we end up with a sum of 180 degrees. Okay, if you are given that angle EFG is a right angle, then the two angles that combine together to make EFG can be set equal to their sum can be set equal to 90 degrees. So if we take this smaller angle here, which is EFH, Okay, that is 2x plus 2. And we add it to the measure of the smaller angle at the bottom, which is HFG, x plus 1. Then we know that that has to equal 90 degrees. Now we're going to combine like terms. 2x plus 1x is 3x. 2 plus 1 is 3. And that has to equal 90 degrees. Now we'll subtract 3 from both sides, and we will get that 3x equals 87. Now we'll divide both sides by 3, and we will get that x equals 29. Okay, that's great. Now to find out exactly the measure of each of these angles, we are going to substitute 29 into each of these expressions. Okay, 29 plus 1 is 30 degrees. Okay, 2 times 29 plus 2 gives you 60 degrees. Okay, when you add those two things together, 60 plus 30, you need to get 90, and we do.